Dear students, in this session we are going to see how the method how to solve the exact ordinary differential equations, exact equations. Okay, exact equations. First, we will see what are the steps we are going to follow. So exact differential equations, and what are the methods, what are the steps you have to follow to solve a exact differential equations. Followed to solve an exact differential equation. What are the steps we are going to follow? Some three steps are there. First one, suppose the exact differential equation is like this: m dx plus m dy equals to 0. Suppose you identified that it is exact differential equation using the condition already we discussed in the previous session. Now we have to identify what is m and n from the exact differential equation. Then what you have to do is, first one, we have to integrate m with respect to x, keeping y as a constant. Keeping y as a constant, you have to integrate it, partial integration with respect to x. Next, integrate those terms in n not containing x with respect to y. Third one, the sum of those two integrals, those two integrals equated to some constant c is the solution of the exact differential equation. That's all. These three steps you have to follow. Now we will go to the problem. First, see the first step, second step, and three steps you have to follow to solve the given exact differential equation. We are going to see the problems now. Solve first one. Solve x square minus 2xy plus 3y square into dx plus y square plus 6xy minus x square into dy equals to. This is a differential form is given, but whether we don't know whether it is exact or not. So first we have to check the exactness of the given differential form, the above given differential form. So suppose this one you treat it as m, this one is treated as n. First you have to check for the exactness. So what is the theorem? We already proved it. How to check whether the given exact form, given differential form is in exact differential equation. So now the above equation is of the form m dx plus m dy equals to 0. Therefore, what is m? X square minus 2xy plus 3y square. And what is n? Y square plus 6xy minus x square. So now m and n is found out. So what is the condition that should be satisfied by this equation to be an exact differential equation? Already we have studied one theorem in the last session. What is that theorem says? If this condition is satisfied, m we integrate with differentiate partially with respect to y, this must be equal to dou by, this is the condition. This condition if is satisfied, then automatically the given equation, this equation is an exact differential equation. Now, so what is dou m with respect to dou y? Partial differentiation. So I get minus 2x with respect to y plus 6y, correct, 6y. So now what is dou n with respect to x partially? Only these two terms I can consider, 6y minus 2x. You see both are equal. Clearly dou m by dou y equals to dou n by dou x. So what it says, as per the theorem, if this condition is satisfied, therefore means the equation, I name this as 1, means that equation 1 given is an exact equation. That is a differential equation only. It is written in differential form. As I already we discussed the definition of differential form, and it satisfies this condition, and hence the given equation 1 is a exact differential equation. So what is the step we have to follow to solve? Now we have to solve the differential equation. Solve means here we have to find y, which is a function of x. So this is a first order differential equation. This is a first order differential equation written in differential form, and it is an exact now. Now what is the condition? First we have to integrate m with respect to x, keeping y as a constant. So you take m. So now integrating m with respect to x, keeping y as a constant. We get, so we have to integrate m with respect to x, keeping y as a constant. So what happens? X square minus 2xy plus 3y square with respect to x, keeping y as a constant. Y as a constant. So what happens here? We integrate it and keep y as a constant. This is x cubed by 3. We are integrating with respect to x. We think y as a constant. Minus 2 x square by 2 y plus 3 y square into x. Okay. Don't want to add here the constant of integration, because the step 1 is just integrate with respect to x, keeping y as a constant. So we get x cubed by 3 plus minus x square y plus 3 y square x. Okay. This is nothing but integrating y, keeping y as a constant, dx. Okay. Next, what we have to do is see the second step. Integrate those terms of n not containing x with respect to y. So here, which are the terms not containing x? Only this term, because this involves x as well as y. You should not consider those terms. This is completely omitted because it contains only x. Consider those terms of y not containing x. If like these terms is not available, that step is omitted. Okay, second step is omitted. So now only y square we are going to integrate with respect to y. Now second step is integrating terms, integrating the terms independent of x in n with respect to y. Okay. Integrating term with respect to y, terms only independent of x, only those terms. So here we get only y square with respect to y. So we get y cube by 3. Don't want to add the constant integration. What's the third step says? Third step is the sum of the previous two values what you got by integration, add it and equate it to c. That is a solution. Therefore, the solution of the given exact differential equation is, the first step, what is the answer we got? See here. See this one and this one, you add both these things. X cube by 3 minus x square. If terms are repeating it, you write only once. That is important. Don't add both and write two terms. Only once you have to write each term. If there are common terms, you write it in both these equations. You take only one of the common terms. Okay. Plus 3y square x plus y cube by 3 equals to some constants. That's all. If you want, you can just simplify this further. Simply I write constant. Finally, I give the name of the constant. So you cross multiply this 3 throughout, take the LCM x cube minus 3x square y plus 339 y square x plus y cube equal to 3 into constant, that is all the constant I named as. So this is the required solution. Okay. Now we go to the next problem. Problem number 2. Solve dy by dx plus y cos x plus sin y plus y divided by sin x plus x cos x plus x equals to 0. So this is one first order differential equation given. So first you have to write it in a differential form. Write it in a differential form. The given equation is written as, see, you take this to the right hand side and then just cross multiply, like this also you can do. So dx into this, so y cos x plus sin y plus y into dx. Okay, when dy into this, see, you take this to the right hand side, you will get minus of this entire term, then cross multiply it, then bring it again to the left hand side. Everything I am just doing in a single step. So into sin x plus x cos x plus x into dy equal to 0. Right? Okay, we get this is a differential form, and this is my m and this is my n. Now we have to check for the exactness of this given differential equation. Here m equals to y cos x plus sin y plus y, and n equals to sin x plus x cos x plus x. So now immediately find dou m by dou y. What is this? Dou m by dou y is cos x plus cos y plus 1. What is dou n by dou x? Sin x becomes cos x plus x cos x cos x, you have to sorry, this is x cos y, I think. I wrote the question wrongly. Yes, this is cos y. Okay. Now we have to integrate differentiate partially with respect to x. Okay. Clearly, this dou m by dou y equals to dou n by dou x. Therefore, the differential form 1 is an exact differential equation. Now, what do you have to do? Therefore, now first you have to follow the step 1. Integrate m partially with respect to x. We get partially means y is treated as a constant. M into dx treating y as a constant. So what is that? What is m? Y cos x plus sin y plus y into dx, keeping y as a constant. Y is a constant. That is what we have to think of. That is called a partial integration. Y as a constant. Better you write like this so that we don't do any mistakes. Sometimes we may we integrate wrongly. So y is a constant, but integrate with respect to x. Integrate with respect to x. So what is integration of cos x? Sin x, y is a constant, keep it as it is, and sin y is a constant, then we get x. Plus here also y is a constant, so we get y times x. Okay. Next step, you have to integrate with respect to y terms independent of x. Which are the terms independent of x in the n? These two terms. Okay, cos y plus 1. We have to integrate with respect to y. Sin y plus I did a mistake here. So actually we have to see n, no? N, this is n. I saw this one, this is n. So you have to see this one, n. Which is a term that is independent of x. Every term is depending on x. So there is no term. So we don't want to perform the second step. So we can neglect it. So this step is omitted. So now what is the solution of the problem? Solution of the first one. That is the first differential. That is a differential form. No? That is a solution of one. Yes. Add these two things. So what is that? Y sin x plus x sin y plus xy equal to constant. That's all. But second step is we cannot find like this term, so you can one more problem is there. Test for exactness and solve e power of y plus 1 into cos x dx plus e power of y into sin x dy equals to 0. So the solution, clearly from first equation we get a m equals to e power of y plus 1 into cos x and n equals to e power of y into sin x. So what is dou m by dou y? This is a constant, no? So e power of y into cos x. So what is dou n by dou x? E power of y into sin x differentiation is cos x. This is a constant. So clearly dou n by dou y equals to dou n by dou x. As per the theorem, this implies that first one is an exact differential equation. Okay, this is exact differential equation. How to solve it? Solution of 1 is given by, directly I can write it. See here, this is m. So what we are going to do? Integrate e power of y plus 1, integrate m partially with respect to x, keeping y as a constant, plus integrate n. What is n? Terms that is independent of x. There is no term independent of x because x is multiplied. If suppose e power of y plus sin x is there, then I can consider only this term, but it is in product, so like this term is not available. So this is equal to a constant. So that is, so we are going to integrate with respect to x. E power of y plus 1 is a constant. We can treat like a constant. The integration of cos x is sin x. This is the solution. Okay, this is a solution of the given PDE. Sorry, not this is a solution of the given exact differential equation. Okay.